Now let's look at question number 2. Now this is almost similar to the previous question. There is a card that has a mass of 100 kg, the total mass of everything on the card. Determine the acceleration. So we want to calculate what is the acceleration of the card as well as the normal forces at A and B. So still the same like previous. We want to know what is the AG, the acceleration of the center of gravity of the card, and what is NA and NB. So remember, the first thing to do is always drawing the free body diagram. All right. So here we have the weight mg. We have the normal force at point A, we have the normal force at point B, and we have the 100 Newton force acting at an angle. So definitely here uh, we have to separate this into two components. So the force 100 Newton will have the X component as well as the Y component. And again, pay attention to the coordinate system here. We still define our coordinate system X positive to the right and Y positive pointing up. All right, so when the free body diagram is done, then we draw the kinetic diagram. Obviously, the card is not moving up. There is no rotation. So the only arrow we have is moving to the right in x-axis, which is magx. All right. So we start with our first equation. Total force in x-axis equal to magx. All right. So like previous, you will look at the force, the left-hand side of the equation in the free body diagram, the right-hand side of the equation in the kinetic diagram. All right. So here, the force in x-axis, there is only one force in x-axis, which is this force here. All right. So you have 100. This is a sine of the angle. If you make this as an angle theta. All right. So to get the x-axis is the force 100 Newton. Sorry, it's not sine, it's cos of the theta. So you can get this is by dividing the 4 over 5, right? And it is equal to, on the right hand side in the kinetic diagram, you have magx. So straight away from here, you can get the value of the acceleration of the card, agx in x-axis, which is equal to 0.8 meter per second. So that solves the first part of the question, which is to determine the acceleration of the card. Now we go to the second equation, sum of Fy equal to magy. You have a few forces in y-axis. The weight is negative y, Na positive, Nb positive, and don't forget this force here, 100 Newton in y-axis. So you have Na plus Nb minus the weight, this is the weight, minus 100 multiplied with 3 over 5. All right. And for the right hand side of the equation, when we look at the kinetic diagram, we don't see any arrow pointing in y-axis, therefore this is equal to 0. So from here, you will get the equation Na plus Nb is equal to 1041. So we cannot solve the equation. We have to go into the moment equation. So now I'm going to demonstrate how you can calculate moment other than center of gravity. So normally we calculate the moment at the center of gravity, COG. But this time around, let's say we want to calculate the moment at point B, at this point, point B. All right. So now we want to calculate the moment at point B rather than calculating it at point G, which is the center of gravity. So now, as I've mentioned in the previous video, when you want to calculate the moment about other point other than center of gravity, then it is equal to the kinetic moment. This is called the kinetic moment. So what is a kinetic moment? If you want to calculate the moment about g, for example, total of mg, then the equation will be ig, the mass moment of inertia, multiplied with alpha. But in this case, when you want to calculate the moment about other point, let's say in this case mb, then it is equal to the kinetic moment. This is how you write it, kinetic moment about point B. So what is a kinetic moment? It is basically the calculation of moment from kinetic diagram. Kinetic moment is calculate moment from the kinetic diagram. So in this case, we will refer to the kinetic diagram. This is point B. So we have only one arrow. So how do we calculate the moment about point B from the kinetic diagram? So you're going to have to know this height here, the vertical distance, which in this case is 0.5. And then you just multiply. This is going to point B in clockwise direction, whereas in here we define counterclockwise as positive, so that's why I have minus sign here, minus magx times 0.5. So that is the kinetic moment. mb is as usual, so you will have the weight. Okay, the weight is going this way. This is the horizontal distance, 0.4. You get the moment of the weight. NA, let's look at NA first. NA is going to point B like this in counterclockwise, so this will be positive. The distance from NA to NB is 0.4 plus 0.6, so you have 1 here, right? So 1 times NA. The weight again minus, because this is this is clockwise, mg going to point B, so it will be negative because we defined earlier counterclockwise rotation as positive. So this will be minus, m is 100, g is 9.81, the horizontal distance is 0.4. So this is the moment of mg, of the weight, right? So this is coming from the weight. And we also have this. This is 100 times 3 over 5, the y component. So going to G is like this, right? So this is going to going to point B is like that, which is counterclockwise. So this will be positive, right? That's why it is positive here. And the distance is this 0.3. So you multiply with 0.3. And the last one is this, the 100 times 4 over 5, right? So this going to point B will be clockwise, so therefore this will be negative moment, and the distance is basically this 1.2 is the distance, is the vertical distance from this x component of 100 Newton to point B. So minus, because clockwise, 100 times 4 over 5 multiply with the vertical distance is 1.2, and on the right hand side is the kinetic moment, minus 100 for the mass m. Ag is what we have calculated here, 0.8, and finally 0.5. So from here, straight away we will get the value of NA, right? Because the rest are all values no variable, only NA is the variable here. So straight away we will get the value of NA, which is equal to 430.6. All right, this is NA 430.4 Newton. And when we have the value of NA, we can substitute this in this equation to get the value of NB is 610.6. So in this tutorial, I have demonstrated how you can calculate the moment about other point on the rigid body other than the center of gravity. All right, thank you.